The last item in the structural data list is the shear line, wall, and opening dimensions, and refer to input information by the designer, which the results are accessible by the following. Go to Table, Structural Data, and then shear line, wall, and opening dimensions. In this section, the dimensions of the walls and openings are represented in Cartesian coordinates into two main groups, the north-south shear lines and the east-west shear lines. Each wall and openings are classified under their respective shear line in ascending order. The type of wall, segmented, perforated, or non-shear wall, as well as the wall group is presented in the table. Also presented in this table are the location, start and end of the walls or openings, the horizontal length, the length of the full height sheathing, and the height of the wall or opening. The openings can be entered by the user by selecting the Action menu and then Openings, or by the Openings icon in the toolbar. The loads generated by Shearwall for the lateral design of the structure can be viewed in order to verify that the proper forces have been applied to the structure. The wind shear loads are accessed by the following. Go to Table, Loads, and then Wind shear loads. The table provided describes each wind shear load that is applied on the structure by representing the type of input, either block, which is used in the load generation, accumulation of loads from one block with another, or manually, the building face, the building surface on which the load has been generated or entered manually, the load profile, the start and end locations, as well as the start and end magnitudes, and finally the tributary height. The wind shear loads can be seen in the plan view through the Generate Loads icon. As you can see, the wind loads can be generated based on line loads or area loads. Either one does not make a difference in the plan view, as the program converts the area load to line loads for the design. However, the difference will be in the results. For the line load, the load profile will be displayed as line and there will be no tributary height associated with it. When the wind shear loads are generated based on area loads, the load profile will be displayed as area along with a tributary height associated to each load. The elevation view of the wind shear load can be seen by selecting the wall of interest and then selecting the elevation icon. The arrow shown here is the total factor in horizontal force applied to the shear wall based on flexible diaphragm wind design. To view the one for rigid, we have to go to Show, Forces, and then Rigid. The wind component and cladding forces are accessed by the following. Go to Table, Loads, Wind component and cladding loads. Similarly to the previous table, the type of entry for the load is presented along with the building face it is applied on and its respective magnitude in the interior and end zones. The wind and component loads are presented in the plan view to the exterior of the wall as well as beside the wall in the elevation view. The building masses generated by the program are available in the Go to Table, Loads, and then Building Masses. The masses are separated by levels, and within the level they are described by their orientation, element of the building on which it is acting, the type of entry, the load profile, the start and end location of the load, as well as its magnitude and tributary width. Building masses can only be shown through the Loads and Forces icon. First we have to go to Show, Seismic, and then Show, Loads, and Building Masses. The masses are represented by two purple circles and a line joining them. The seismic loads generated by the program are accessed by the go-to table, loads, and then seismic loads. Again here, the forces are separated by levels on which it is applied and furthermore classified by the direction it is acting, the load profile, start and end location, as well as start and end magnitudes of the loads. The loads described are typically the ones automatically generated by the program. To access the other types of loads, such as wind shear forces, dead loads, uplift loads, and seismic forces, one must input these type of additional loads corresponding to the representation of the real structure. Entering manual loads is done by accessing the loads and forces icon. Let's say we want to add a wind uplift line load to wall line B, therefore click on Add, Wind Uplift, Line Load, Apply to wall line B from x equal to 0 to 50 with a magnitude of 10 pounds per linear foot. And then select OK. Rerun the design and go to the Wind Uplift table by selecting Go to Table, Loads, and Uplift Loads. To view the load in the elevation view, we have to select wall line B and then select the elevation view icon. Then we have to go to Show, Wind, and then the wind uplift is displayed. In order to enter wind shear forces, dead loads, or seismic forces, the process is similar to the one previously described. Deleting or regenerating automatically generated loads is done through the two following options from the Generate Loads icon in the toolbar. Deleting a manually inputted load is done through the Loads and Forces icon. Selecting a wall will allow you to see only the loads applied to that wall, while not selecting any wall will display the loads for the entire structure. Then, if there are too many loads, it is possible to select what type of loads to show by clicking on the Show button. By clicking on all but the Wind Uplift tab, it will allow you to see only the uplift loads. Click on the load you have entered and delete it. Now to see all the loads applied to wall B, select Show All. To see all the loads applied to the structure, click anywhere in the plan view except on a wall. You should now see all the loads applied to the structure. This concludes the tutorial on the explanation of the structural data and generated loads tables in the results output. The next tutorial will describe the wind and seismic shear results tables.